Okay, good evening. Let's get started. So I actually made an offer to any of you that need helps. I started here 6 o'clock, but that's only to help some of you that has problems. Let me see. So we are using if you can't use the FTK, you can use the AIM, and I think the AIM should have worked. So just to give you an update where it is. So if you look at the OneDrive, I updated the OneDrive on the same night where we had our last week lesson. FTK is here, but if your computers are not compatible with FTK, you can use the Arsenal image mounter. I think some of you can use this fine. Okay. After the guest lecture, I would like to introduce you to another tool, which is very useful. I think these two are going to be very interesting, so we will try that later. Okay. Why don't we start with the guest lecture first, then we continue the lesson later on, okay? Okay, so it's my pleasure to invite today's guest lecturer, which is Ria. So Ria has an interesting story, and I will let her introduce herself. And she will also share some stories about her experience. And she specialized in quite a different area than the previous speakers. So I will let her share with you, and then probably you can do a Q&A with her as well. So Ria, please come over. Thanks.
Thank you. Okay, but I think it would be very quick. Hi, everyone. Okay, so forward and back. Let me test. Where's the, should be here? Okay. Okay. Thanks, Leonard, for inviting me, and hi, everyone. Okay, so today I'm going to share about my experience, and actually like a scenario or an incident or a situation that I encountered at work, which will probably give you like a deep dive of how, like a cybersecurity professional is, like a day-to-day life of a cybersecurity professional. What do we deal with day to day? What are, like the type of problems that we solve, that we encounter? What are the communications? What are the, the people that we deal with at work? So that you have a glimpse of, what you're probably going to do. This is just a facade, like one portion of, like, the whole cybersecurity is very big, right? You can be in the first layer of defense, second layer of defense, wherever. So my talk will just be very specific and doesn't constitute the entire cybersecurity. Okay, but okay, so the title is The Rise of Machine IDs, and that is because machine IDs. Okay, maybe before I start with that, I'll just introduce myself so you have a context of who I am. I am Rhea, and I've been in the IT security industry for almost 15 years now. So I started as like an IT infrastructure network person before cybersecurity was a thing. And, when cybersecurity becomes very, famous and talk of the town, I moved to a consulting firm and does like cybersecurity assessments, network assessments. It's like a cybersecurity consultant, okay? And 7 years from consultancy, I moved back to commercial, particularly healthcare and financial industry. Financial industry is a very, very highly sought after industry for cybersecurity professionals because they are highly regulated and they're being mandated to have a very, very like mature cybersecurity infrastructure. So I am currently in the financial industry. As I've mentioned, cybersecurity is a lot of things. Mine, for example, right now, I am very working specifically on an area called identity and access management. So in a mature and highly regulated organization like financial industries, they basically divide their pillars and identify which of the areas that they need to focus on. So, of course, GRC is one of them, and identity and access management is also one of them, which I will uh, tell you more about later why it came about. Um, Outside of work, I do cycle. If you guys are cycling, you can probably see me in the road, so just say hi. So every weekend, we do like round the island cycling. Sometimes, if we're lazy, we'll just do TMCR if you know where that place is. And okay, I won't be staying here for the entire class, but I will stay probably until half of the class. If you have questions, you can approach me. But other than that, you can also reach me out in my LinkedIn, so you can add me and just say hi and that you're from NTU. Okay, so my talk today is about a scenario that I encountered at work, which I considered a bit unique because it's something that we, that I did not see often, right? And it's related to machine IDs. And I will tell you why it's not like very common because the way we actually bucket um, IDs right now is different in the past, and the rise of machine IDs actually creates like a lot of gaps in terms of how we are protecting them, and what are the processes and what are the solutions that's already in the market that is out there that will that will help to control and protect the machine IDs. So maybe I'll start with defining what are the different types of PIDs right now from the current definition in the in the industry. What are the available protection and solutions that's available right now to protect these IDs to ensure that they are secure? And then what are the gaps that we encounter with the current that we encounter that we think are there with the current solution that is available? And then what are the mitigating things that we actually implement to ensure that those gaps doesn't happen, the risk in terms of those gaps doesn't happen to your organization. And I'll start it with the story that I mentioned about, like business as usual days. I went to the office, and, if you're someone that's working in the first line of defense, like security operations, if you're doing forensic, you're probably a threat intel or doing threat hunting, or, just someone managing all your security ops, right? My role is actually part two lots, one lot which is first line and sometimes second line. So very common. This is actually one of those. Cybersecurity is exciting, by the way. Very technical. You need to be go in depth, but you also do boring stuff. Okay, and this is the boring stuff that I'm talking about. So some of the boring stuff that we do is basically to deal with audit findings, right? So as part of the second line of defense, we have governance, risks, and assurance and compliance, right? And compliance basically are the people that check if all of your controls are in place, your baselines are followed, if your change management is working as it is intended. So they did all that, and they found that I have a finding. Finding is basically an anomaly or something that you are not following a control, or this is not protected, and because this is not protected, the organization is exposed to risks. So the finding, as per the observation and background column, it says that there are privileged service. It's on the privileged service account management, and two service accounts created by. Okay, it's the application team. I just drafted because it's confidential. Used for API For API use and automation were not managed through the group's privilege access management platform, which is not compliant to group privilege access management standards. So nonetheless, Norris assessments was performed to assess the nature of these accounts, blah, blah, blah. And as these accounts, so this is a risk, as these accounts are used to query data, insufficient management over these service accounts may increase the risk of data leakage and the loss of confidential data such as, okay, I masked the organization confidential, they cannot flash it to you. Then they have given you a remediation plan. So remediation plan is what they think needs to be done in order to, avoid the risk, right? So they have written a lot of things, and of course they had assigned it to me. So what are you going to do with this report is you're going to take it back, and you have to do two things. So one is you're going to agree that, okay, the finding is correct, and the risks is sound. The remediation plan is sound, so I'm going to implement it. Or you're going to go back, do analysis, investigate, and then challenge them and tell them that, nope, I don't accept this because it is wrong, and I don't think this is the right remediation plan that we're going to implement. So I'm going to challenge this. We're going to write something else. And also your observation is wrong. So you can do that. So you'll take it back, and then they're going to do a rewrite. Okay, most of the time, our objective is, of course, we wanted to demonstrate that we are following all of the controls properly, right? So we shouldn't have a finding. But if really we need to have a finding, at least we, like the rating here, the medium rating here, at least should be not high. It should be low, because it will, bells and whistles will be all over if it is very high risks, right? So you're going to pull it down. It used to be high, by the way, and we managed to pull it down to medium after we did investing, which I will tell you and share to you later. So this is the usual thing. So I brought it back, talked to my team, discussed with them. So this is what we have, and let's try to see whether this is correct or not. So before I dived in, let me just maybe describe and define some what do you call these definitions here. Right now, IDs or accounts are bucketed into two types. So in the industry, right, it's an industry standard that IDs are being bucketed into two types, which is the standard ID and the privilege ID, or what you call PID. Okay, so standard IDs are your usual interactive accounts, like your normal Windows login that doesn't have any privilege permissions, no admin privilege, nothing. Just if, like, for example, you're someone doing payroll in your organization, you're just given access to the payroll function or module in your finance system. So that's standard account. Privilege ID is elevated, so admin. Okay, I don't need to explain. And then it can either be interactive and non-interactive. Interactive is when you have like a human person, like someone who will key in the username and password, like personally or by a human person. Or non-interactive, which are the service IDs, those that you use in your API calls, or if you have any batch jobs or scripts, you can put all of those service IDs. So it's non-interactive, no human intervention involved. Now, why there's so much fuss about IDs, and why there is a dedicated person just looking after identity and access management? Before it wasn't. It's always bucketed under, the rest of the other cybersecurity stuff, right? But I'm pretty sure you've seen the MITRE stages, right? Familiar? So privilege escalation. So in order for an attacker to advance to the rest of the other stages of the MITRE attack, they will have to perform a privilege escalation. So that is why if you don't have your elevated privileges, your PIDs protected, then that's already one stage down for the attacker to advance their attack, right? Most of the organizations right now are already implementing what they call a defense in-depth strategy or initiative in terms of protecting their organization. And defense in-depth is basically when you put controls into each of these different stages. If, let's say, you're using the MITRE attack. And why identity and access management also became important is because of the, like how we are now very interconnected, right? So before, people are just in the office, but now people can be everywhere. And before, you can only connect corporate computers, but now you can already connect your iPad, your your personal devices into your network and access it, right? So with that, then the need for ensuring, like, you have zero, maybe you can implement the zero trust, what do you call, capable, we can call it capability, but zero trust, or you basically have to ensure that identity and access is managed from the onset. That's how it became very important. So standard ID, privilege ID. Okay, so going back to my story, gonna come back on the how did we investigate and verify, right? So if you see here, under the observation, they mention about 2 service accounts, which is created by my application team for API use and automation, and that these accounts are used to query data and sufficient management, blah, blah, blah. Now, with the definition of the previous definition that I shown about privilege ID and standard ID, you will see that, when I went to my application team and asked them, hey, you have 2 service accounts that are privileged and you never declared. We're supposed to put it in our PAM, Privileged Access Management, which is CyberArk. Pretty sure you're familiar. They're CyberArk, but you didn't. Why? And then they said, why will I put it in CyberArk? It's just a standard account, which it is a standard account, right? Because, this account actually, by definition, it's a standard account because it doesn't have admin privileges. It basically, just query data for a specific, like a specific type of user in the organization, which is correct. But what is not correct is this is an RPA, so it's a robotics process automation where they create like a program or software script to automate this specific process that this person do in order for that machine to basically do like transactions that's impossible to do by humans. So going back to my example of payroll person, right? So maybe in a day he can probably process 50 transactions for the payroll, but RPAs can do thousands or hundreds. So then they said incorrect. So they're right? But the risk is still there because when someone gets into, the RPA, so imagine the risk on the availability, how many transactions that will be lost if this RPA is compromised. And then they said, are these accounts used to query data? Insufficient, blah, blah, blah. So they said, no risks. All standard accounts can query data as they need to perform the jobs, as what I mentioned. Then they challenge, so if you look at here, right, the thing that they mention about is data leakage and the loss of confidential data. So that's the risk if the privileged account gets compromised. But actually, we went back to them and say, so this is the, something is wrong here because we don't really, confidential data is not, it may be compromised, but it's not the first thing that gets compromised. It's actually the availability factor where, if you, just for example, DDoS, right? So if there's a DDoS, all service gone, money lost, but no confidential data that's lost. So that's it. And then they say, okay, I agree, fine, no confidential. And then in our organization, because data confidentiality sits in the top tier, and its priority that's considered high. Availability, because we don't really process. It's still a priority, but not as high. So that's why we managed to pull it down to medium. And then so okay, fine. They agree with the medium, so I'm happy because it's not anymore bells and whistles. But still, and then we're going to have to look at into the remediation plan. We still have to remediate. We still have to apply the recommended action points that they had written in the report. So they said, okay, we'll have to enroll these service accounts into PAM. And then there was also another finding that the management was informed that there is a lack of capability to support the discovery and monitoring of these accounts that are labeled as application privilege IDs. So if you see, there are now two problems here, right? So first problem is you have a privilege ID or a high risk ID. Let's just call it privilege because at this point it doesn't really fall into the bucket of privilege. So we'll just call it high risk ID. High risk ID that is not protected properly, meaning not onboarded to the CyberArk. And the other one is there's no discovery. So technically, if we discover all of these IDs at the onset, we don't even have this report in the first place because we already have it flagged and probably have implemented the controls in place prior to that. So first problem, the enrolling, right? So okay, I agree. Let's enroll. So this is, by the way, like an example of like a console of CyberArk UI. The UI, is it like I'm not sure if it's a client or it's web, but this is basically what you see if you are someone who's trying to withdraw. Anyone here is not familiar with CyberArk? What is CyberArk? Or any privilege access management solution? Okay. So basically, if for those that don't know, if you have a PID, what we do is we basically put controls in the PID to ensure that it doesn't, we don't, the MITRE attack, that privilege escalation, we prevent that. So what are the controls that we put? We make sure that we implement robust password complexity. That's for one. We make sure that we implement multi-factor authentication. Make sure that we implement just-in-time login, meaning I can only log in at a specific time. 48 hours after that, it expires. Then we implement lockouts. We implement rotations, right? So we do all that, and back in the day, we're actually doing that manually, like on the AD, configure it, blah, blah, blah. But the risk is if you have an operator person or an admin, he can just change the settings and blah, you're not protected anymore. CyberArk or any privilege access management solution in the market right now automates the entire thing. So you will onboard your PID into CyberArk, and then if, let's say today, I'll say, I need to access my database as a DB admin. So what do? I'll go to CyberArk request. Your request to access the PID for use will have to go through a series of approval. There's also another control. Once approved, they will not give you the password, by the way. It depends on the connector. So if it's a really very good integrated application, it will be seamless. Once you get the password, you can go ahead and use the application without having to know the password at all. So depending if it's, you're connecting through SSH or a web portal or a VM, RDP, depends. So that's CyberArk. So they wanted us to go in there and put those privilege IDs to let CyberArk manage it. I'll just call it PAM. And there are also different ways of enrolling CyberArk, right? So there's one that I mentioned about full automation, where you don't see any password at all. You just click on you just click on this connect button, and after you click on the connect button, then you will get the interface of the application or the server that you want to log in. There's also another one where, it's impossible to do a fully connected, fully integrated. So we will do a split password. So split password is you have, the application team or the person is requesting has half of the password, and the other half is owned by the PID team. So they will withdraw, and then so no one person has the password. So this is what they recommend, because CyberArk right now doesn't support a couple of different languages. For example, R Studio for the R language. I'm not sure if you're familiar. It's basically used for large computations, like in banks when they do in asset management for trades. So so CyberArk doesn't support full integration as of yet. So we recommend the manual integration, which is the split password. So we did that, blah, blah, blah. Of course, when you are working, which is also what I advise, and which is also why I actually tried to do engineering work even after I've already done like a information security officer, because at work you will encounter very, very experienced and technical people. And if you are a security person, you need to know how to ask the right questions, right? So, like for example, when I went to them, by the way, this person is my business team, and business team could be your, uh, like your quants team, quantitative strategies team, or whatever, which are very, very, use very technical people. They have very good knowledge and grasp on technologies and everything. So they did tell me like, okay, Ray, I'm gonna tell you that this is not going to work, and this is not going to address the risk. Why? Because I can just call the password, even if they're split, right? But because it actually looks like Python if you're gonna look at it. So if I'm gonna go to RStudio and then just use the get pass function print, I can actually see the full password. So I have the full password. So we're not resolving any risk because I still have the full password. So we're just putting a layer of something, of a layer of control that doesn't actually solve our problem. And I said, makes sense. So now how? I don't know. So I went back to my solutions team and then tell them, hey, we have a problem, which is a very, very real problem, right? We can maybe close one eye and accept, just let them on board the password, but it's really stupid, right? It's going to lose the trust. Like, okay, the information security people are really not applying, efficient controls. It's just, like check marks thing, which what we shouldn't be doing. So then we realized that we actually, our privileged access management solution actually have one module or one function that it should have that supports these types of scenarios, which is, in CyberArk they call it Application Access Manager. So Application Access Manager actually solves this problem because in your code, instead of you keying in the username and password, right, even though it's masked, which you can unmask with print, what CyberArk does is you will use a URL, and then you call the URL in your code, and then that code will go to the CyberArk server, and then we'll ask CyberArk, it could be a REST API, and then ask them like, I am a server and I want this password so that I can run this code. And then authentication authorization happens if it's just, for example, REST. Then say, okay, you're authorized, you're authenticated. This is the password. But of course, you don't see the password. So in that manner, we basically don't display the password like this one. So we have removed the risk that they mentioned about, the print of the password. These are just examples, by the way. It's not like the actual real. Just because they mentioned about RStudio and the get pass, which looks very similar to Python get pass function, but it is how it looks like. Okay, so this is the AAM. So just an example, right? So for example, this is the URL, and then this is your code, and then you just put that in the code, and then you know, uh, call it and retrieve password, blah, blah, blah. Okay, I'm gonna go to the technical. I'm not a very technical person, but you need to at least understand how functions work and how to at least read it on a very high level manner. Okay, so what we did is, what is this? Okay, before we do that, so going back to this, right? So we managed to change this that we are not enrolling the service accounts to PAM. We will utilize the AAM, which is the application. Yes. So, and then we changed. Oh, so this is actually one of the problem. We're still not done. So there's another problem. So it said like right now, there's no capability to discover and monitor the use of accounts. So in the industry today, if you have, like your database administrator accounts, the default ones, the AD, your maybe default security groups, can be scanned and can be discovered. So you can use different tools. I've seen people and some of my organization uses Qualys. So they scan, and then what they do is if they discover that, hey, there's a PID here in this server, or maybe in this Active Directory, there is PID and it's being used in these different servers. So they will discover. So there is a discovery. What we don't have, and then after the discovery, we basically flag it and say, hey, these PIDs are discovered and it's not yet onboarded to your PAM, so please remediate this issue, right? The problem now is with application PIDs. And I think the reason why there's no scanner, I will just call it scanner or solution in the market right now on application PIDs is because of the nature that these, PIDs are created. So applications can be different flavors, right? So there's no such thing. And then also like the way you call, the way you name your roles, the way you name your permissions can be everything. It can be everything. So there's no hard and fast rule for application PIDs right now. That's why it's actually one of the high risk in most of the organizations, because like for example, I have an application and then I created different roles. So this role is an IT role, this role is a developer role, and it's a native application, doesn't call any SSO or whatever. Then what happens is this role I can assign like an admin privilege to change permissions for user accounts, for example. But will my scanners know that this is privilege? Nope, it can't, because there's no structure right now that allows it. So I think, so how do we mitigate that as of the moment is we basically utilize the identity and access management workflow solution that we have, because if your organization already have like a centralized IAM solution, it actually can view all the different roles for all of the applications in your organization. So what you can do is you have to go through this very manual. You have to go through each and every application teams. In my case, that could be 100, 200 if it's a very large MNCs, and ask them like, hey, for your application, for these roles, for these permissions, which ones are considered privileged? And then we will mark them, we will tag them, and once we tag them in the workflow, all of the accesses that are granted under that roles and permissions will be flagged as PIDs. It will be checked against what's onboarded, and if it's not onboarded, then that's flagged. But it is very manual. I'm not sure if there's already a solution right now in the market. I think last time we checked was 6 months ago. But I'm pretty sure that we are probably very near with Gen AI, deep architecture, right? So we can always create something and let it analyze and whatever. So we just probably wait. But right now, that's our answer to this, because we need to provide. We need to provide a remediation plan for that specific risk. Okay. So, so this is what I mentioned. The PID tagging is manual, relies heavily on declaration, and IAM solution identify entitlement types of roles in the workflow. Okay, lessons learned, last slide. So app ID, so application ID discovery right now is still, there's no available solution, right? So maybe when you go out of school, it's probably something that you want to, you know, want to do, want to discover, create a solution. Machine ID classification. So the way they classify ID is based from standard privilege, but actually with the rise of RPAs, APIs and whatever, right? We use more APIs right now than normal administrators. So I think we will have to rethink the way we categorize PIDs at the moment. And this is just my opinion. You could have your own opinion. Into human and non-human IDs. So at least we know like humans interactive, non-humans, then we can have standard accounts, may not have administrative privileges, but could be high risks. So yeah, the rise of machine IDs and app ID discovery. I talked so much. Questions?
Okay, any question for Ria? It's a bit too much. It's a lot of to digest, but when you do forensics, so far we've been learning how to check something has been done through user account, through someone. But what Ria is mentioning today is about machine ID. Sometimes a lot of transactions, a lot of system events are done by machine. You know the IP address, then you know the host name, but after you find out the host name, you need to know whether this machine is running on, is one of your known machine, and what user accounts are inside the machine. And what Ria mentioned is that some of this account management could be local, could also be centralized. If it's centralized, you're using those systems like CyberArk. CyberArk is a very expensive system. All the banks use it. It costs millions of dollars, right? But that's the only solution, one of the best solutions we have in the market. Okay? So Ria, I think thanks for your lecture. I think if you're going to stay around, right? So I think,
Yeah, I'm gonna stay around like
yeah.
help the class. So you can
No worries, yes. We will take a break probably later. I can interact with you.
Okay.
All right? Let's give a round of applause to Ria. Thanks.
Thank you.
Yes. Okay, so before we go to today's lesson on memory forensics, I just want to recap quickly to help you get back on track, because last week we have some technical issues, right? So I posted on the same night, there's another way to mount the image using an Arsenal image mounter. It's also a free software, and I know I've spoken to some of you, you're able to mount. Anyone still not able to mount? Anyone still have problems? Can you raise your hand? Okay, if you still have a problem, please look for me during the break. But I think most of you should be either able to mount using FTK. Some of you can, some of you cannot. But for those of you that can't mount, you can use Arsenal. Okay, either these two should work. So I want to also highlight that I uploaded a couple of new things on our lab share folder. The first one is a VM. So you have the Shift here. You have the Windows from Microsoft. You can either use this or you can use your own Windows evaluation. You can choose either one. Okay. Then on the tools, I uploaded the FTK is here. It's been here, and there's Arsenal image mounter, which you can also use. Okay, so you got either of this. After this, I would like to introduce you to a new tools on how to analyze all the registry in the Windows. What we have learned last week is to do it manually, right? So you have, okay, let's do this, right? If you do it manual, right? This is how you do, this is a super manual, right? So you can see everything here, but it's pretty hard to find information from this because you need to know what information at which folder, at which subfolder, and so on. Okay? If you still remember, if we want to look at the time zone, where do we look at the for time zone? you still remember? From last lecture, I think it should be somewhere machine. Do we use system, software, or security? Do you remember? System, okay. Then current control set, I think. Do you remember anything else? Let me see. So let me just take a look at the, say again? Yeah, this is control set. Let me see, which one is that? Say again? Search. The search is not really useful. Let's see whether you can search. Yeah, you can find. Yeah, you can actually find here. But you really need to know what's the keyword. Because time zone may not be time zone, maybe TZ. So if you don't know what's the location, you don't know what's the keyword, it's pretty hard to work. This is a bit difficult work because manually, everything is manual, right? Then the second option is to use the registry Reaper, which is, it's Registry Explorer, which is this one. And we did this last week, right? If you remember. So this is also an option, but it's still manual because you need to know where it is. Now I will introduce something which is interesting. So, which is a Registry Reaper. But before you do that, I'll show you how to do this end to end from the start. First, you need to do a load the Hive. Let's go to. This is a desktop, I think. I think it's a. Let me see. Yeah. So F. So what is? Let's see. What is F? Let's see what is F. So F is. Okay. So F is desktop. Okay. So because remember you got two machines. One is desktop, which is the client. One is a DC01, which is the server, right? So remember F drive is the desktop, and then, oops, sorry, I was mistaken. F drive is the server here, okay? The desktop is J, okay? So F server, so the first one is server. So let's do Registry Explorer. Close this so you don't get confused. So we start from the beginning. F, which is the server. Let's go to Windows, System32. Then we use config. Okay. And then we choose, let's say we choose system. Then remember what I say, because there are some unwritten transactions. So you need to say yes, and then you need to select this and this together. Okay? Okay, once you do this, it will ask you to save the combined file. So you can, let's say, save it here in Documents. And in order for you not to confuse yourself, you can always say the host name, dz01-system clean. Okay? So we do this for each of the four. So now you have system, right? I will close this. So you don't want to confuse yourself. After you do this, you just close it. Then you open again. So you started with a clean interface. Just wait for it to be open. Okay, so you need to do this a few times. We do F, Windows, System32, config. So just now you did system, let's do software. So out of this 4 database, only 2 are very important, system and software. The security and SAM, not so much, but you can do it for completeness, you should do it. Okay, same thing again. We go here. Okay, now one of the biggest mistake you can do, you load software, but then you added another database, log 1 and log 2. So don't make that mistake, okay? Okay, so you've done this, we do the same thing again. We say software here. Okay, so now if you look at my so if you look at my files, now I have a DC01 software and system. I can do the same with the SAM with security. Then I repeat with the desktop 4. So you should have 8 files altogether. Okay? But that's the manual. So how do we make it even better, automated? So I have this tool called the Registry Reaper. There are 2 versions. One is version 3, one is version 4. Okay? So let's download the version 4. Then we go to downloads. We extract. I already extracted. Just need to run this application called rip.exe. Okay, this one is fine because it's not signed, so just run anyway. Okay, then it should run. Let me see. We should have run. Let me close this. Sorry, my mistake. So you should be running the rr.exe, not the rip.exe. Okay, run this one. Right, so then you need to load the Hive files. You cannot use the straight from the Windows System 32 config. You need to use the one that you have combined. Okay, so let's say we take this system, and you need to generate a report. So let's just use the same folder. Okay, then I just put .txt on it. Then you click on RIP. So what it does is actually reading the database and putting it on a human readable format. Okay, so it's done. Let's take a look what it looks like. So this is the file here. You can see the file I think it's quite big. It's 200 kilobyte is still okay. Then you open with Notepad. So you can see here, the files is something that you can read better. Just now was like many folders, so many folders, it's hard to see. Now everything is analyzed and formatted nicely for you. So depending on what you want to take a look. So for example here, you want to see certain things. Let's see, time zone, let's say, edit, search. See this? The time zone, right? The time zone, you can see that here, Pacific Standard Time. And then it's also they also write more things about this. For example, whether it is 7 hours or 8 hours. This is compared to GMT, right? Because GMT or UTC 0 is the standard, right? Then when you say 8 hours or 7 hours, is either plus or minus, right? And can you tell me why there is either 8 hours or 7 hours? Yes, very good. In Asia, we don't have daylight saving. Only in Australia, Europe, and US, right? In certain months, I think in October to March, So October to March, yes. The clock is either shifted 1 hour later. That by March, it shifted 1 hour backward. Okay? So in this case, Pacific Standard Time is probably 8 hours behind. But because of daylight saving, it's actually 7 hours. It's very important because otherwise your forensic report is all wrong. Okay? So you can see a lot of things here. For example, IP address and so on, you can also find here. So this report, this tool are very good because then everything is here, you can search. Or you can read slowly one by one if you want to. This, you can read this. With the Registry Explorer, you cannot read because it's very difficult to read. Okay, any questions? Yeah, you can use 3.0, 4.0, anything is fine. Any question about this? Should not be difficult, right? Okay, later on you should try, and if there's any issues, you let me know during the break, okay? Okay, I'm going to continue with the lecture today. I'm going to switch back here again. Probably we do about 15 minutes, then we take a break. Okay, so just a recap our schedule. Today we are doing memory forensics. Next week, we're going to have our first quiz, first exam. Okay? The exam, as you remember, is a 40 multiple choice question and 2 short answer. Short answer is short answer. I literally have a 1 page with 2 questions and I give you a box. So do not write more than a box. It's actually very short. It's not meant to be a long essay, it's just a short answer. Okay? You have 1 hour to do that. Generally, I think if you read the slide, you understand what it is, you did a bit of hands-on, you should be okay. All right? For quiz 1, I'm going to test it you from topic 1, 2, 3, 4. So today's lesson is not included. Okay? So just the first week, second week, third week, and the last 2 weeks. Okay? Right. Any question? And next week, I also will brief you about the projects. So by next week, we should form a group. I will brief you what's the project all about, the assignment, right? And yeah, I think that should be the program for next week. Okay. So for this particular course, there is this website that I will like you to use. This is your reference slide. So you don't have to buy any book for this. Okay. So when you go to this website called digitalforensicmadness.com, you look at the, let me see, is it the lab? Yep. So we are going to use so this is our labs here. Okay, if you can read more about the lab, but we're going to use this. For today's lecture, if you want to understand more, we're going to use these particular articles, but these articles just give you how to do things, walk through you, right? But we're going to do hands-on in this class. Okay? All right, so let's get down to the some of the theory so that you understand more, then we will do hands-on. So, do you still remember this, the 2 slides? We aim to answer all the questions. And on the last week, we are able to answer IP address, time zone, host name, correct? And the Windows, the operating system version number. That's what we can find from simple computer forensics. Today, we're going to answer a few more questions using memory forensics. Okay, just move forward this. Okay, so as I mentioned, Memory forensics is very simple. We are not analyzing the disk, but we're analyzing the memory. Okay? The memory is a volatile data. Means that the data could be lost. Okay? Can you tell me in what way the memory, the data in memory is volatile? Or how data can be lost? Freeze means what? Freeze the RAM. I don't know how to do that. Freeze the RAM. No, I mean how the data can change. Or how can you lose the data? Yes, if you power off the computer, right, there is no electricity going to the memory chips, then the memory is gone. So the difference is with your SSD or with your hard drive, even when you turn off, the data is still there. But the memory is different. There's no power, all the data on the memory is gone. That's one. Secondly, in what way the data in the memory can change? Pretty much everything that you do, you run an applications, you do something, your memory keep on changing. In fact, the data in the memory keep on changing every seconds. Okay, so that's why it is volatile. Okay? And because of that, because data is volatile, if you are a threat actors, you are trying to compromise a machine. Some threat actors prefer to load their malware in the memory, but not on the drive. So we call this a fileless malware. Any idea why would you do this? So you don't want to download anything. Everything is only executed in the memory. Yes, to avoid detection. Because if nothing gets written on the disk, you can do your computer forensics, there's no proof that a malware was downloaded, a malware was executed, there's no proof. Because everything happened in the memory. Okay? So this is why we need to look at the memory as well. Okay? So just a quick computer science. In the memory, you got, in the CPU architecture, you got north bridge and south bridge. And typically memories is on the north bridge. Okay? There's also a different controller, but they don't really deal with memory. It deals with a USB hub, with all kind of connectivity. But the memories are actually on the north bridge. Okay. So how does RAM look like? Actually, RAM is just like SSD, as I said, just a different type of chip. Okay, so you can see the definition here is it requires power. Once you turn it off, it's lost. But what is the benefit of RAM compared to SSD? Which one is faster, RAM or SSD? RAM is much faster. Okay? And there are different types of RAM. From DRAM, dynamic RAM. This is your standard memory. We call it DRAM. There's a static RAM. Static RAM is like your BIOS chip. So this is even if power off, the data is still there. But static RAM is actually very expensive and it is a bit slow. Okay? But it is there. Then you have a VRAM, which is a video RAM. This is for your GPU. And typically VRAM is even faster than dynamic RAM. Then you got NVRAM. This also been used in your BIOS as well. So that even if you power off, there's no battery, the next time you charge your laptop, then your computer still know what time it is because it has a bit of this a memory that is not volatile. Okay. Then you have this SDRAM, which is typically used in a different configuration. Okay. So I'm just going to go very fast here, so we can go straight to the hands-on. So we are going to focus more on running process, because every process that is running, every application that is running, every file that is open, it will have a copy in the memory. Okay? Any malware that you run is also going to be evident in the memory. You cannot hide it. It has to run on the memory. Even if you run rootkit, for example, sometimes some advanced rootkit can fool you. You basically say, let's say certain processes are not running. It's actually running. So it actually fools your task manager. So there are some rootkit that does that. So you cannot trust what you say, but whatever the malware will be running on memory. You can also capture the system state analysis. So this is like taking a picture. You see at that point of time, what is your IP address, what application is running, who is logging on, what data is loaded to the memory, and so on and so on. So how do you get memory? There are many tools that you can use to grab memory. There's a free one, for example, this. Typically we use Dumpit or the WinPMem. That's free. You can Google it. You can download it. You can also use your favorite tools that you don't like, FTK Imager, that you can run memory acquisitions. One of the best one in the market is called F-Response, but F-Response is very expensive. Okay. You have three options. You can do it live. I think live is when like this computer is running, I would download WinPMem and I will capture the memory, right? So that's typically how we do it. Secondly, if the computer is dead, if the computer is power off, is there any data on the memory chip? No, there's no data in the memory chip. Remember RAM? If your computer is power off, the memory chip has no power, it has nothing, there's no data, it's empty. But remember, computer have a hibernation file. Do you know what hibernation file is? Yes, correct. It's actually a copy of your memory. A copy of memory, you put it on a file. So in the future, let's say this is actually nowadays it's not so common, but it still exists. If I'm working on my computer, then I want to stop. I don't want to work on my computer. You have two options. You shut down or you put computer to sleep, correct? These days, we don't really shut down. For convenience, we just close the laptop, it's automatically put on sleep. But sleep takes battery. So let's say if you put your computer to sleep without power, how long do you think your computer can last? Well, a few hours to 1 day to 2 days. But if you leave it for a very long time, the battery discharges slowly, and then ultimately no power, then your system shut off. It's not clean shut off, it's just power off. If you have any unsafe data, it's gone, right? So there's another third way, which I used to do, which is we put the computer to hibernate. What it does is that it captures the memory, put it on the file, then it's actually power off. So the next time you press the power on button, it will read the file. It will restore the memory so that whatever application that you're running, whatever files that you have opened is reloaded. Okay, so that's what we use hibernation. Because of hibernation, it's a copy of your RAM. Even if your computer is off, you can still grab that file, so you can do memory analysis. Okay, likewise, swap file. These days, if you buy a Mac, the default configuration is what? 8 gig of RAM. And we know that it's not enough. You run a Chrome 10 tabs, it definitely, your RAM is full. So one way of operating system to get more memory is by creating a file called swap file. It's actually an extension of your physical RAM. Because it is an extension of your memory, right? You can also analyze that. You can either do this locally or remotely. Locally means the computer is here, you acquire the image. Remotely, you logged on using PowerShell or SSH, you install the application, and then you run the software and then you download. Okay? So typically you can do it this one time during an incident, you just do it. Or if you are monitoring a system, typically during the containment or during the eradications, you take the memory, right? You clean it, and you take another one, and then you compare it. Is there certain processes still running? Okay, so I'll go this slide and we take a short break. The problem with memory files, memory is not a structured file system. So do you remember the file system? We have a table of content, like a file, FAT, MBR, NTFS. This is a structured file system. There's an index. This file is located at this sector. In memory, there's no such thing. Everything is like put together, right? So each of the application knows I put data here and here, but there's no written master boot record or file allocation table. There's no such thing. Okay. And because of that, if you want to analyze memory, you need to know certain things. Either you know what operating system it's running. If you know what operating system is running, you roughly know the profile. The operating system will use this memory to this memory. Or you know the applications, right? And you use debugging symbols, and you know that, oh, this to this, and this data means this application. So you need some kind of reference, because it is really just a random data. Okay? And as I mentioned, that it is very volatile. So when application is closed, memory is changed. Application is refreshed, everything is changed, right? So it's very volatile. Okay. Some good malware will have anti-forensic. So for example, if they will detect if there's an attempt to read the memory space that the malware is using, then they will just do something. It's like a logic bomb, right? So some malware is very smart. If you try to access the memory space that the malware is using, it will erase itself, so that you cannot do any forensics. Okay. All right. And also there are some malware, right, which is very interesting, like WannaCry, the very first famous ransomware. This WannaCry will not activate if there is no internet connection. What is that? Thunder? Oh, rain, okay. So you cannot go home now. So WannaCry, right, is a ransomware. It's actually a well-designed ransomware. It will not encrypt and it will not execute if there is no internet connection. Can you tell me why? Any reason for it? Yes. Yes, correct. So WannaCry is is a malware to earn money for the threat actors, right? If when you encrypt data, they need to send the encryption key to the server so that they can pay and they can give you the decryption key. So the malware actually has a logic. If I can't get internet connection, then I may not encrypt, because if I encrypt, you pay me, I also cannot give you the decryption key, right? So it's actually very smart. And because of this, the memory pattern is different. So for the same malware, if you do not have internet connectivity, you analyze the memory, there is no encryption subroutine. But if there is internet connectivity, the memory pattern will change because there's encryption. Okay? All right. I stop here. Let's take about 10 minutes break, and then we'll come back. And feel free to engage with Ria if you have any question.
The
How do you, okay. This is Arsenal. Okay, then click more. Then where is your image? This one, right? Okay. Then this device only, okay, this is correct. Arsenal.
so we have to
Huh?
do this
This
for
one.
all other files, all other folders.
You only have two images, right?
Yeah.
You already have this. Okay. So then you need to do the same thing with the other image.
Okay.
But make it not easy, not difficult, because some people get it, some people get it. But no, there's no one here, so last semester no one here. So don't be the please.
Tadi siapa yang
Dari,
dia dari mana?
dia dari East Spring.
Oh, East Spring. Is it also medical
No, East Spring is East Spring is
investment?
investment bank from Prudential. So Great Eastern.
Oh, is it? I thought Great Eastern is going with OCBC. Not true. Okay, okay. But I also use CyberArk, but as a user, it's not like, but she's more specialized as a PAM, right? Yeah. Privilege assessment. You here or not? I haven't done this before.
Yes.
So to double confirm about this like so actually I don't really quite understand in the sense that like the maximum file size it goes from very small 1 KB all the way to 16 GB. Like if let's say a question it really come out like say what is the maximum file size for MTFS, then there are so many different games. Then which one should I choose in a sense?
So this one is a cluster size. I think I'll clarify this. This is the cluster. It's the smallest unit size. So you see that this exabyte and petabyte, which is bigger?
TV I think is bigger.
Really?
I'm not very sure, but I know after TV is PB. So probably after PB is TV.
I think should be better. Should be bigger. Okay. So Exa is bigger.
Yeah, PB is bigger than PB. So EB, PB, TV. After that, then you have GB, MB, then KB.
Okay, I think I will clarify. This is more of a theoretical unit. Here we don't have this kind of, we don't use this unless we use a cheaper computer.
Yes.
But many people actually it's cheaper to buy a smaller unit, so then it's better to together. Yeah, don't worry, this will not be a session.
Because I did search online, Google, GPT, whatever. They all give me different answers.
Because there's an RFC document specification. People just use this pretty much for solving terabyte over those cases. Unless you specialize in
Okay. So, same for the is X 2, 3, and 4, right? I'm working on projects. Custom test project. I'm also working on my partner's project. Step one. Now for Windows test.
Okay, let's start again so that we can go back home on time. So I'm going to cover a few more slide theory, then we get a bit of hands-on. The best tool to do memory analysis is called volatility. We've been working with volatile data. The tool is called volatility. It is a free software you can download. There are two versions of the software, version 2 and version 3. Version 2 is still being used, but more and more people move to version 3. So what is the biggest difference? The volatility runs on Python. So version 2 runs on Python 2. Version 3 runs on Python 3. that's the biggest difference. But the parameters are different. The plugins are different. So I will show you probably a bit later. So with this volatility, right, it doesn't matter. You can run on Windows. You can run on Linux. Choose one. Doesn't matter because it's run on Python. Okay. There are a lot of articles on the internet. Just read whether you want to, how do you install volatility in Windows? How do you install volatility in Linux? Okay. For today's, I think it's easier for us to do it in Windows. In Linux, I will show you how to install it. Okay. I think, yeah, sorry. Yeah, that's so if you use Shift, it's already pre-installed, but it's pre-installed at the volatility 2. I would actually suggest that you go to install volatility 3. So how do you do that? You need to copy this file, the Git repo, and then you use this software to install volatility version 3. Okay? Okay, so later we will try this, okay? Okay, so how to use the software, very simple. Use Python space vol.py and then space the file name of your memory image and space the parameter, the plugin. So volatility has a plugins, depending on what you want to check. Do you want to check running processes? You want to check network connection? You want to check whether there's a malicious code in the memory. So they have many plugins. So in the first example here, you are doing PS list, process list. So what it does, as you can see, it lists down all the processes. Okay? So when you look at these processes, if you look at this, right, anything that you would be suspicious of, anything out of the ordinary, yeah, so probably everything looks standard. Perhaps this one is a bit something that is unusual. Does it mean that it is bad? May not be, but something to check. Okay? So process list is definitely one of the most useful plugins. Okay? So how do you do that? You take a look at a few things. Process ID here, right? This one here, the first column, is called process ID. Every process has a process ID. Why? Because you can run the same files into multiple processes. So every process will have like a serial number. We call it process ID. Okay? Now, process ID typically run in sequence. So if you run this for the first time, let's say 100, process ID number 100. You run a second time, it's 100.01. Then it gets killed or gets shut down. Then you run again, it's 102. So it doesn't repeat. It's actually go up. Okay? The second parameter is a parent process ID. So what does it mean? Sometimes, right, this process will call out to another process. So then you know that, okay, this particular process, for example, this one, right, SVC host, there's a different process ID. But the parent process ID is 636. Okay? So what does it tell you? That this process 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is all initialized or run by the same process, which is process 636. Okay? So which one is process 636? Is it here? here. Right? So now you know that this thing here is run by this one. Okay? Okay. So that's how you link them together. The next one is the name of the image, which is this one, the file name. Right? This one. Then you have the offset. This is the memory location. So that's why I say that unlike structured file system, there is no structure in memory. They only have a memory address. You can see the memory address is all different. Okay? And then what is interesting for us to look at create time and exit time. Create time is when the process is run. Exit time when the process is terminated. Okay? So let's go back here again. Do you see because of these files, right? These files here, they are run by the same process. But how do you know whether these services run them together or run them one by one? You can't tell from the numbers, but you can see from the time. From the time you can see that it's all the same time. Means that when someone runs this, either script or you run this application, it will run all this application at the same time. Right? So this is how you tell whether it is like, okay, load 2, a few minutes later, load another 2, or they run together. In this case, it's run together. Okay? Now, when you look at the exit time, right, it say not available. Can you tell me why it's not available? The process is running. That's why there's no exit time. Unlike the process here, which is process number 312 here. The 312 has a exit time. So you know you got the create time, you got exit time. You know how long a process runs. In this case, for this process, right, let me use the cursor. Let me see. So in this case, right, you can see this is running on 7:28 in the morning. It's also running, okay, so in this case, this process only runs for 1 second. Okay? So this minus this. Okay, anyone got this slide before I move on, or you got a question? Yes. Ah. Mhm. Okay, good. Good question. There are two questions here. The first question was, this time, what time zone is the time? So anyone knows what's the answer? What do you think this time zone? Okay, the answer is depends. By default, it uses the system time. So if the system is running on, just now on Pacific time zone, then this will be on the Pacific time zone. But as a forensic investigator, you need to check. Sometimes Windows uses UTC time on the logs, but it's not consistent. Sometimes they use UTC, sometimes they use a local time system. So you need to compare what data, and you need to Google it and see whether this information, the create time, is it local time zone or it is a UTC. You need to check. So that's your first question. His first question is very good as well. This particular process, the CSRSS.exe, the parent ID is 412, but you don't see 412 anymore here. So what would be the reason then? Yeah. Yeah, so the process has probably been ended or exited or terminated, but it's exceeded a certain time. So it's no longer kept here. This one, if you look right, why the exit time is still here? Can you check the time is very close, 7:28. This is still 7:28, so these are still very close. But this one probably the parent process has been terminated a long time ago. Say again? Good question. You probably can't because it's a volatile memory, right? So if this computer has been running for 5 days, and then the parent process ID probably only run at the startup when you boot up, but it's been 5 days, so the parent process ID already killed, so you can't find it anymore. Say again, sorry?
So if the parent got killed, either the child process got to get taken over by the PID1 or it's also get killed. Why there is also one?
The question was, if the parent process ID was terminated or killed, then what happened to the so-called child process, right? So it will not change. It will still refer that this application was called by this process ID. Okay. It's not, how is this different? I don't think it's different. It should be the same. Yeah, so there are many scenario. One scenario could be, because, okay, when you run an applications, there are two ways, right? It could be self-contained, meaning that you run your DLL and so on, you run the processes within that application. So when that application is terminated, all the child processes terminated together. That's the expected behavior, but it doesn't always the case, because these days the way we build software, you build a software, you call other libraries. Let's say your .NET and so on. I mean, you use a different library. So that processes may be shared with other software. So when you exit your application, your whatever you call is still running because it may be used by someone else or another applications. Okay? Right. So this is another way to use it. Okay, you see here. Here you have a PS list. Here you have a PS3. Okay? So what is the difference? It's the same. The only difference is, you look at this. It has a visualization. This is a parent ID, right? This is the root level. Then this process ID of 312 is, the parent ID is 4, so you got 1. This is the first generation, second generation, third generation, and so on. So it's like, right? So then you know that this process ID are on the same generation. So just for us to see better. Okay? It's a different how many child down. So for example, this 6112, right? It is, the parent is this one. So you see that there's a one generation or one star. This and this is like cousin, like brothers, same generation.
So does that mean that first generation, they are being running before than the fifth or sixth generation?
Yeah. So coming back to your question, actually the same, right? This is Chrome, right? If I kill this application, right? If I kill this application, which is WinLogon, WinLogon is your login system. If I kill this, right, does it terminate all Chrome? May not be, right? But you can try, you can try later on your computer. Tell me the result. Okay, so PS3, remember this. Some of this will come on your exam, by the way, but not this quiz, the quiz 2. The next one, which is quite useful, is NetScan. So NetScan is different. We want to look at the processors. We also want to look at the network ports that is listening. Because some applications, they listen. Like if you're running an FTP server, you're running an email server, you're running a DNS server, it's listening on certain ports. So in this case, you see this application is listening on what protocol, what IP address, what is the local port. So this tells you at that point of time what applications that is listening at what port. Okay? So you use this NetScan. And these are the description. I think it's quite self-explanatory. Now, let's look at something interesting. So this is a real example, right? If you use the same thing, which is the, so this is the output of this, right? This is the output of Windows NetScan, okay? So what is interesting here? First of all, when I look at some of the public IP address, I need to check, is this process supposed to be communicating with internet? Right? That's my first red flag. Secondly, I would like to look at whether the process name seems to be legitimate. In this case, the process name is a bit strange, SMS forwarder. And this is exactly the type of malware whereby they will catch your SMS or one-time password and send it somewhere else. Okay? So in this case, you know that this IP address is connected to this foreign IP address. The status is closed, means the session is already over. This is the process name, and this is the time. Okay? On the next one, you see it's the same IP address, but it's connecting to a different IP address in the internet. It's connecting to different port, and it is using a SYN. Are you here familiar with the three-way handshake? We will learn later on the network. Do we have one? Yeah, I think we will learn later in one of the modules. So you got SYN ACK, you have ACK, right? So in this case, it tried to send a connection. Okay, and then you also can see that. Yeah, it's also done this. So you can see some interesting stuff here. Okay, so if you want to know, then what is this IP address? You remember on our first or second lecture, you can go to this website called virustotal.com and put in the IP address, and you see whether it is a known bad IP address. Okay, and you know that this actually is a malware. And these are the name of the malware. Okay, next one, which is very interesting, is called malfind. It stands for malicious find. So these particular plugins try to scan the network, the memory for malicious code. Okay? Do you know what is this piece of code? What language of code is this? It's assembly. Have you heard about assembly? Yeah, assembly language is more like a CPU programming language. Nobody code in this code anymore. But if you can code using this, your software files, right, file size is very small. If you can code in assembly, instead of hundreds of megabytes or tens of megabytes of exe file, you probably got 5 kilobytes. 10 kilobytes, because you're really coding using this kind of CPU programming language. Okay? Okay, so for this particular code, what do you think it is malicious? So just look line by line, and why do you think this particular plugin thinks that this particular code is malicious? What is interesting here? Which one? This one? This just tells you that this particular memory space can be executed, can be read write, just like file system can be execute, can be read, can be written. Okay, I can tell you, the suspicious thing is always this jump. So jump typically means that when you execute a code, normally you execute top down, but the hackers try to execute some other code somewhere else in other part of the memory. So then you will inject this kind of instruction, okay, ignore the one bottom here, just go to this memory space and execute whatever in this memory space. Okay? Okay, let me repeat that. Normally it goes top to the bottom. You execute this, you execute this, you execute this, and so on and so on. That's the normal behavior of application. Okay? But if you are a threat actors, you want to insert, you want to replace an instruction, ignore the rest of your code, you go to a different location, and you execute the command of that application. Understand? Okay. You can, but you can also, that's why you need to take a look whether this jump command is legitimate or it is not. Think about shell code. Have you do you know about buffer overflow? Right? So typically when you do buffer overflow, you try to rewrite a particular memory and you say, okay, execute my code on other memory address. And that's why jump is always quite suspicious. Okay? Okay, so we learned the basic. Let's go to our case. Okay? So this is the memory, the URL. And what we're going to do is that, first thing first, right? In this slide, they are using volatility version 2. So how do I know this is volatility version 2? Is it version 2? Let me check. Did I use version 2 here or version 3? Yeah, I actually use version 2. Now, version 2 is not so smart. When you want to analyze a particular memory file, you need to specify what version of the operating system. Okay, they are not, so let me repeat, the volatility version 2 is not so smart because you need to tell them what version. If you tell them the wrong version of operating system, it will not understand the memory image, it will not be able to come up with this pattern. So this is why your first forensic, when you analyze the disk, you use the Rack Reaper or you use the Registry Explorer to find out what is the version of operating system. And that information, you can use it here. So from computer forensics, you continue with memory forensic. Okay? Now because of that, volatility version 3 came out. The version 3 is smarter. You don't need to tell them what version of operating system. It just runs. Okay? So can you remember again, although the name is slightly different, but you can look at the keyword. So what does this particular plugin does? Yes, it's try to identify a network connections here, okay? Right. Okay, so this is an actual analysis from the case study, which I'll give you a real demo later, right? So if you were to do this right, you will see some suspicious process. First of all, the name is suspicious. It's called coreupdater.exe. The name is suspicious. And then what else suspicious? Connection to the internet. Yeah. And you look at the status, established. Means that the three-way handshake is done. There's active connection. When there's an active connection, means what? You can transfer data, upload, download, and so on. Okay? What else? So we use the plugin Malfine, and if you remember, Malfine analyzed the memory and looked something interesting, right? So in this case, it found out that okay, there is this process that is suspicious, and the name is Windows Exploit Metaprinter. And do you know what is Metaprinter?
It's like used to create backdoors or
Yes, but what is the name of that framework?
MSF console.
What MSF stand for? Metasploit, right? So Metasploit. Anyone here heard Metasploit? If you're going to be, if you're aspiring to be a pen tester, penetration tester, you need to know Metasploit. So Metasploit is like security tools whereby you can execute a lot of vulnerabilities, a lot of exploit. Okay, so Metasploit UI is called Metaprinter. MSF Venom is to create a binary files. So here you can see that this particular computer, which is DC01 data center, you have evidence that there is a malware running on it. Now, with this information, right, in your interim report, can you confirm that the server was hacked? Can you confirm that there's an incident? Yes, you can, because you found that there's a malware running on your server. So it means someone successfully compromised your server. Okay? Then we do this. Do you remember what modules we use for this? The one with this parent? Process tree, yes, very good. Okay? And what is interesting here? Remember, we were interested about this core updater. So how do I trace it back? You can see the process ID is 3644, and the parent ID is 2244. The trace down 2244 is, let me see, where's 2244? Wait. So this goes here. This goes, where is the, I don't see 2244. Yeah, so means that, yeah, so this is exactly back to the point, right? It is actually gone. So we can see it. Okay. Say again. Not really, if you remember, it was supposed to be sequential. Yeah, it could be truncated. Okay, so from here, you can answer this question. Was there a breach? Yes, because you found evidence the server was compromised. You can answer this question now. The first two questions we already answered on the previous slide. This one we already answered. This one we still cannot answer. We don't know how the server was compromised. We can also answer that the process that is malicious is core updater.exe. Okay. What else? We know the IP address because we use NetScan. And how do you know this? How do you find that the malware sits on this particular folder? If you know the file name, then you can go back to your image that you mounted, try to find where is the core updater.exe. Okay? But let's see whether we can also see somewhere from here. Let me see. Yeah, it doesn't have the part here doesn't have it. Yeah, it's not here. But you should be able to search for it. Okay? And we also know the date, because if you look at the files, then you see the date. So we will take a look later on. Okay? And what is the malware? It's Metasploit. Okay? Is a malware easily obtained? Yes. Metasploit is a freeware you can download from GitHub. Okay. So then, if you know Core Updater, right, then you should also be able to look for this. Okay, why don't we go quickly to this? Yeah, let me switch. Let me see to here. See that? Because from the memory analysis, you know that there's a process called coreupdater.exe. Since you know the file name, you go back to your computer forensics, you search for the file name, and there you see. This is DC01, F is DC01, Windows System 32. So you know that the file is there. Okay? So then if I want to know whether this file is malicious, I can open up a browser. I can go to VirusTotal website. Okay? Then I can upload the files. I go to F folder, say Windows System 32. I go for Core Updater. There you go. Open. There you go. So, do you know how to read this? So there are 75 antivirus engine. Out of 75, 64 found this malicious. So it means 80% found it malicious. So it means that very good chances it is a malicious file. Okay? Then from here, you can get a lot of information. What are the name of the malware? What is the details? What is the, see this? All the hash files, when it was created, what are the different file names, right? These are all the different file names. Then you can see how it is behaving, right? You can do a lot of things here. So now you can see, right, from a forensic image, we do computer forensic, we do memory forensics, then we can search, then you get a lot of information. Can you see the linkage now? Okay. Okay, so what else do I see here? Sorry, those students on the other side, can you still see this screen? Can you see this screen? You can, right? So we will use this to screen, okay? Okay, so coming back here, right? So this one, we confirm on server. I have not confirmed on desktop. So how do I confirm on desktop? I can do the same thing. I can run a memory analysis on desktop. I can also search the file on desktop. So let's do that again now. I will go to J. I will search Core Updater. Is this file present in the desktop? Okay. See? Yes. So we confirm this. We confirm the malware present in server is also present in desktop. But if you want to have a second confirmation, you need to run a memory analysis also on desktop. Simply because the file is here, doesn't mean the file is executed. So how do you prove that the file is executed? it is present in memory. Okay, so actually all these things you can see from the Forest Total website. Okay, so why don't we go to do some hands-on. So this is your Shift Forensics. Okay, so your Shift Forensic only comes with a volatility 2. So how do you check? You can do vol.py, and you can see that this is version 2. Okay, so how do we install volatility version 3? So let's follow the article. Okay, you can just Google it easily. Okay, so you can use this. So the first thing we need to do is to install a Python tree. But I think Python tree is already installed in here. So what you need to do is just this. Copy this command. So I'm going to delete my own copy. Then we will do it together. You want to do it together? Just fire up your Linux VM, okay? Okay, let's do it together. You just search on this an introduction to volatility tree. Look at this. You should find this article, because if you have it, it's easy. You just can click and copy here, right? Okay, I'm waiting for you. You have all your VM up and running. If you have VM up and running, open up browser on your VM, and please go to this website. Yeah, I'm going to wait for you, and we do it together. Okay, any questions? Okay, if not, I will copy this. I will open up the terminal. I will paste. And what happens is just press enter. Oops. Let me see. Oh, okay, because I have it, so let me remove first. Okay, now let's do it again. It should work now. Yeah, so it's downloading. After it's downloaded, the next step is to install the volatility tree, because when you do git clone, right? When you do git clone, you're just downloading. You're not installing yet. Okay. So what we need to do now is to install it. And you will see a lot of this. After a while, it's downloaded. So how do we know that you have installed? You can run this. Okay, so now in the Shift VM, you have two volatility, version 2 and version 3. So you can see the difference here. Do you see this? Oops. See this? Volatility 3, right? So this is now volatility 3. Because I'm running it on the local folder, volatility.py, and it's running on version 3. If I don't use this dash, I'll just do this, right? It will actually run volatility version 2. Okay, so you need to go to the directory of this volatility tree where we download, and then you need to use this dash. Oops. You need to use this. So it means that you're running the volatility on the current folder. If you got it correct, as I said, you should see this version 3. Okay, you should get this. Okay, I pause here. Does everyone able to install this? It should be quite fast. Actually, you can also run on your Mac. Yeah, can you open up the website that I give you? So this is the website, right? Slash introduction or unique, I think. Always miss with you. With a small screen, you can take it. Big screen. There's a very small screen like this. That's the first one just now. Yeah, click here. Yeah, scroll down. Up. Yeah, copy this. Copy this. Click on this. Copy. Yeah, then put it on your. Can you do a right click? Copy. Paste. Yeah. Okay, good. Then copy the next one. Enter. Okay, it's installing. So what is that? Let's see. What does it say? Oh yeah, this is just cancel. It's okay. What's wrong with the bigger machine? It's so small. So you're okay, right? You're fine? Okay, good. You look install. Done, right? You just need to do a dot slash for dot slash. Just like my command here. Dot slash. Yeah, slash. V. Yeah, VOL dot py. Yeah, enter. Yeah, good job. Yeah, I think you done it right. Can you guys do it? Yes. Okay. Are you okay? Just Google it or use your search engine. Or your phone or yeah, here. Just this one. Scroll down. Scroll down. Up again. Yeah, this one. Good. Copy. Okay, good.
Figured out.
Just copy over. Just copy this, copy this.
Okay.
Okay, who has not done? Anybody has not done? Are you okay? okay? You can? Oh, this one is okay. Just press enter. You can ignore this one. Yeah. Just press cancel. It's installing. Just press cancel. Press cancel.
Cancel.
Yeah. Yeah, it's actually running. Can you make it bigger, full screen? Yeah, okay, good. Are you okay? How come
Don't worry, just.
you're okay? Not okay? What? Yeah, then to check whether it's down or not, you need to run the command /. This command, okay? Okay, if you have installed and you want to know whether it's working or not, you should use this command. Use this command. See, it should come up with this. And the command is, just use this command here. So /fall.py. Sorry, which one is, what's the problem?
When I open go to the last screen, I think maybe I do some wrong settings.
Okay. Yeah, I think this one should be, because we use the same VM, I think you need to check your VMware. But
Yeah, because I use VirtualBox and I put the maybe.
please use VMware. VMware works. Okay? You okay? Yeah. Okay, good. Most of you have done it. So please use VMware. We know VMware, and this is working. If you use other tools, I can't support you because I don't have VirtualBox here. Okay. The second step, you need to move your memory images into your desktop here. Okay. So I actually have moved these two files here. Okay, where do you find the files? Okay, let me show you the files. The files is here. Yeah. Okay, these are the files that you need for this lab. See this? DC1 memory and desktop memory. Okay, you need these two files. Copy over to your, you need to copy over to your you copy over to your folder, and you need to unzip them. Once you unzip them, it should look like this, .mem. Some of you know how to copy and paste, right? You click and drag or copy and paste. Or if not, actually there are three ways. You can click and drag. If click and drag doesn't work for you, you do copy and then you do paste. If it doesn't work, you can do what I do here. I set up a shared folder and I just copy over to desktop. So I mount here and I copy over to desktop here. Yeah, so I was able to copy here. Okay. So I'll wait for you. Okay, I'm just testing something. I will explain to you a bit later. So your job now is to copy over the mem file into your VM. Okay. Okay. Let me check who has copy over your memory file to VM. Okay. 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 Please help each other. Okay. If your neighbor don't know how to copy, please help them. But you need to move the mem file into your VM. Okay. I'll just give you 1 more minute. Then I will show you what to do.
The lab files need to be in the same folder as volatility.
Yes. To make it easier, copy over the mem file into your volatility folder. It's easier. Okay. So my command and your command could be slightly different because I place the mem file in another folder and I'm actually on a volatility folder, so slightly different. But I mean, these are basic Linux, so I should know. Okay, what you need to do now, if you can copy over, then you just need to do this. Okay, for PY. Then depending on where you put your memory files, if you put it on the same file, then it should be here. You just put desktop something, right? But in my case, I actually put it on the previous folder. So I actually put it like this. Oops. Okay, so this is the syntax, okay? The for py space dash f means file. Then you specify where is the memory, where do you store your memory files. So all your commands start with this. Then the last one is your modules, whether you want to do PS3, you want to do PS list, whether you want to do net scan, or you want to do whatever, okay? So let's say I try to do malfind. Okay. Oops. Let's see, what is the command? So there's another website here called Volatility Cheat Sheet. So you see that this particular website, I quite like it because it tells you what are the command for version 2 and version 3. So since we are using version 3, I will click here, 3. Okay, the first thing you need to do, let's say Windows Info. Okay, so I'm going to do that. Okay. And you can see on the left here, is doing a lot of analysis. So wait for a bit. Okay, so based on this, right, you can see this is the output. It's basically tell you that this is it. Not really helpful, but it tells you that major version 6, minor version 3, so it's 6.3, and these are the timestamp. So I think if we were to look, so you can see 6.3. Okay, let's see what was just now was 6.3.34404. So it's not really a precise, but you can basically see that it's 6.3. So what is 6.3? Is this Windows Server 2012 R2, which is we discovered, remember, on the 2 weeks ago. So which is correct, right? So let's try to do the same analysis with another one, which is the desktop. So it is 10.0. Okay, 10.0. So let's take a look what is 10.0. 10.0 is Windows 10. So it's actually also another way. So you can see, right, to get the same information, you can look from registry, you can look from memory analysis. The more methods that you use and pointing to the same result, the stronger your argument is, and the less false positive. Okay? Okay, so that's the first one there, right? So we use this Windows info, right? So that's how you use it. Second, PS list. I think you have seen the PS list. I've demoed that. Proc dump, not so useful. Let's take a look at, let me see. We can use at Windows command line. Okay, let's take a look. What is this? So you can actually play around with it, right? So now you know that these are a list of applications. Okay. But let's see anything more interesting that we can see. So this is the network, NetScan and NetStat. Let's use the Malfind here. Windows Malfind. So in this, if you look at it, there's a lot of processes. Some of these are false positive. You got PowerShell. PowerShell is not malicious. PowerShell is not malicious. We know that. And do you remember this one? I think this is one of the parent process ID. So very likely the core updater is run by this. Okay. Okay, I think I demo enough. You can play around with all the parameters, but now let me know if you have problems. Because if you can run it just like me, you can just change the last parameter. Anyone can you run it? Are you able to run it? You can?
No, low battery.
Low battery, okay. You want to charge?
Oh, you use it.
I've got USB-C. Are you able to run it? Okay, good. So I suggest you play around with it. You can see different output. Okay? Very good. Yeah, then you have to wait. No, yeah, okay. Yes. For PY, Ash, Windows Mobile. See, you don't have this one. You see, it doesn't have necessary. So you're running for utility tree, correct? Correct. They say, oh, you don't have a write permission. Can you run with sudo? Try to run with sudo. Put your password. Try that. Fine. And what? That means that you are running. You're not running as an administrator. Yeah, I will wait. Yeah, let me know whether it works. Okay. Are you able to run it? Okay. No, he's okay. You can run sudo. So what is your problem? Yeah, just in front you run sudo. Yeah. Okay. It's working? Yeah. Okay, good. Does it run? What is the error message? No, what is the error message? So sudo -for projection, project files. Okay, can I check that? Is this correct? Yes, correct. It should be working, but it's correct. Correct. I think your memory image is corrupted. Yeah, can you unzip again? I think your memory image is corrupted, but your command is working. So how is it? Are you able to run the command? Okay, have you copied? I can see. So I cannot see the memories. Yeah, I can see the memory files there. It's okay. It's coming. Are you okay? Can run? Yeah. So you can run with the command. Yes. Desktop, Windows 4. Okay, I think you have the same problem as me. I think the memory image is corrupted. So you have to copy.
I first the longest command and I get the same results and I wait up 3 minutes and then run again. It's working.
It's working?
Yeah.
Strange. Okay, then you can try again. what's any issue problem?
I download the VMware to upload on here, and when I want to set up, and it said I need to restart. Is that strange?
Yes.
I need to collect yes.
Try, yes.
Really? I'm so be afraid.
I wonder which document or something I should analyze.
Have you copied the .mem file here? The memory images?
Oh my god.
Your screen is very small. My eyes cannot read.
Because I can see.
Okay, is there HDMI here? Can you plug to the computer? Is there HDMI?
Yeah.
Okay, they come in. Okay, you got a problem, you let me know, okay? I think most of you are able to run it. Okay, if you are able to run it, you can play around with it, try to answer those questions. Then when you're done, you feel free to leave, okay? It's a big file. Okay, any question? If you have any question, please come here. Or if not, yeah, play around. If not, then you can also leave. It's up to you, okay? But I'll be here. Yes.
This volatility, this tool is only can only be used in command line.
Yes.
So whether it's on the Linux or
Yes, because it's Python. It can run on Mac, can run on Windows, can run on Linux. So this one is done. You can see this is the output, right? So now you can just play around with this. Use this command. You can change to different command. Let's say PS list, right? Just now was, let me see. Oops. You can do PS list, correct? Yes.
so I installed this volatility
Yeah.
tools, and what shall we do next?
Okay. Next, you need to run the. Have you copied over the mem file inside
Mem file.
the memory image?
This one. Right.
Yes. Okay, just put it here. Okay, you have any question?
Is this 2.10.0 long?
Yeah, that's correct. Okay, and you can take this.
Oh.
You can take this, and you can bring your computer here. Thank you. Good, right? Okay, yeah. Connect to the screen. You have any question? Yes.
I was wondering the next week the quiz is the questions like the slides
Yes.
and
It's all in the slide.
or is
Yes. Okay.
So just need to follow the instructions.
You have HTML. How to going to see it? Yes, here. So you are done, right? Are you okay?
If I have question,
Yes.
can I just send email? Maybe. Yeah.
You have my email address. On our first lecture, I will give you my email address.
Okay. Yes. Because maybe I have no time. I will just get my leave maybe Friday and until Thursday. Yeah.
You have what, sorry?
Oh, aku cuti mulai hari Jumat.
Oh, sana kalau buat belajar.
Yeah, from Friday to Thursday because there are 2 exams for next week. And no time.
Okay.
Sorry.
HTML is not working. process tells you what are suspicious. Networks tells you really what process is being made. Right? Yeah, these two are easy, correct? Small things, high reward. This is the high reward, small, high effort, small reward. Okay? Yeah, okay, thanks. Okay, any other questions? You all excited for this new piece? Yes.
There is a practical on this. Do we need to do all of this?
No, that's actually just already. Okay, I'll explain.
Okay.
Okay, just before you go, let me grab your attention real quick. Just before you go, just a quick one. Um, so you go to this website that I mentioned, it's on your slide. Okay, so you go to labs, you go to second page. Sorry, you look at memory analysis here. So I want you to follow this, but remember these are using volatility version 2. So you need to map the command to volatility version 3, okay? But here you can follow exactly how do you find certain evidence. For example, let me see, so script all the way here, memory analysis. But they're using volatility, you use image info, which is very easy, right? You use the windows.imageinfo, right? That's the command. Then you should be able to see similar result. Then you can also use this NetScan, but I think the command is windows.netscan, so you need to translate to volatility version 3. So you can follow all this thing, okay? Okay, so pretty much running the same command, then you should be able to follow what is the finding, how do you find evidence. Okay? Yeah, so this is like exactly what we are trying to do, but they're using an older version. What I'm sharing with you is the newer version. Yeah, just follow up. Okay? All right, good. Okay, any more questions?
So there's a lot of record of the net behavior. How can I find the yes?
You have to analyze anything interesting, anything suspicious, and so on. I mean, there's no trick and so on. The easiest way you put this on a text file, and you read this only one.
Any rules that I can follow? Like I
Just now I showed to you, right? I mean, okay, these are normal, right? Now when you see there's a connection, external IP address, then that's suspicious. So for example,
first thing, do I need to?
if I do this, right? Because now you know the answer. It's called Windows with Morphin. That's your volume P3, right?
PID. Exam same room, right?
Yes.
Yes. Okay.
So is it computer based or